Okay, we have here the integral from 2 to 3 natural log 1 minus e to the minus 5x dx. Now to get started with this one, the first thing I want to think about is just the graph for this thing that we have over here to the right. If you think about just this e to the minus 5x part from 2 to 3, this right here is going to be a really small number, so it's going to be just slightly less than 1. But natural log of 1 is 0. So what's happening is the whole integral is going to be really close to 0. On the graph, we can see it. If you look from 2 to 3, even if you look in Desmos, it looks like it actually is just 0, but it's technically not exactly 0. So if we could estimate it, we would just estimate it as 0 and be done with it. But what we're going to do is integrate it and find this really small number. And the nice thing about it is kind of a nice result, even though it's going to be close to 0. So to start with the integration on it, what I want to do, let's do a u substitution just to clean up this part right here. So I'm going to set my u equal to e minus 5x. If I take natural log on both sides, we have natural log equals minus 5x. Let's isolate x, and we're going to have, let's see, x minus 1/5 ln u. And then take a derivative, so our dx value is going to be minus 1/5 u du. So then I'll just go ahead and substitute, plug in 3 here, e to the minus 15. Let's write it as 1 over e to the 15 here. And then same kind of thing with the 2, it's going to be 1 over e to the 10th. This part's going to clean up to just natural log 1 minus u. And the dx is going to be this. The minus 1/5, let's bring that out front as a constant. We have the du, and then we just have this u in the denominator. Let's write it like this. But now for this thing right here, this is really close to our definition for the dilogarithm. Let's just look at that integral definition and compare it to what we have here. So for the dilogarithm, I'll give 2 definitions over here to the right. The first one we don't really need right now. But anyway, here's our series definition for the dilogarithm up top. But what we want to use is our integral definition that you'll notice this part and the part inside, that's exactly the same. It's just a difference of the bounds. And we do have a minus sign out front that we can use. But actually, I think what I want to do with the minus sign for now is let's use it to flip our bounds. Just because 1 over e to the 10th is bigger than this, so I'd rather just have the larger number up top. And then from here, in order to use the formula or get it kind of close to the formula, let's write this a different way. So I'm going to just force this to have the lower bound as 0. So this is going to change it, but only for a moment. And now with the lower bound 0, it matches this, except for the minus sign, which we'll fix later. And then in order that we're not changing it from this, I can subtract off the area that we added. So if I just subtract off an integral distributing in the 1/5, I'll create another integral. And for this one, we'll go from 0 to 1 over e to the 15 of the same stuff. All we're doing here is this principle over here, which allows us to add the integrals together and update the bounds. And then if you rearrange this to get from here to here, all I did was subtract off this one on both sides of the equation. And so now here we're basically ready to use this formula. We've got the 1/5 in common. Let me just kind of write it as 1/5 in front. Then for this piece right here, it's going to be dilogarithm of this. Notice the input is just the upper bound here, as long as we've got 0 for the lower bound. So this is going to be just dilogarithm 1 over e to the 10. But because we don't have a minus sign on this one, we just have to change the sign here. So this will be minus dilogarithm 1 over e to the 10. And this one's going to be plus, same kind of thing, dilogarithm 1 over e to the 15. And then I'll just reorder it and put it all over 5. So for my final solution to this, we have dilogarithm 1 over e to the 15 minus dilogarithm 1 over e to the 10, all over 5, and that's it. Okay, now I did get a numerical estimate for this on Wolfram Alpha. As you can see, it's going to be a really small number like we saw originally. But I think even the more interesting thing is when you look at the graph on Desmos, you really have to zoom in to get any sense that it's not 0, because you zoom in and it still looks like 0. And so you have to just like zoom in, zoom in, zoom in, and eventually you might be able to find something. So if you just zoom in all the way on Desmos, make the font on your computer as large as it possibly goes, eventually you'll be able to see like every single pixel on the screen, but then you'll also be able to see that the area is not just 0. Okay, that's it for today. Thanks everyone for watching. Have a good day.